Hello, this video is about using graphs in Science 9. What you should learn after watching this video is number one, how to figure out a value on one axis when given the value on the other axis. And two, how to compare the rates of change between trend lines or moments along a single trend line. So to practice these skills, we'll start with how to figure out a value on one axis when given the value on the other axis. And for that, I have a graph here with a simple story about two cars traveling along some road, a red car and a blue car. And on this axis is how far they are from home, and this is the amount of time in hours that they have traveled. And so to illustrate these different skills, this particular skill, I have four questions. Let's start with question A. When the blue car has been traveling for 2.2 hours, how far is it from home? So the proper way to answer this question is not to look at any particular data points on your graph, but rather on the trend line. And that's all I have drawn here. So here's how we're going to go about doing this. We're going to find down here on this axis, the time axis, we're going to find 2.2 hours. Now 2.2 hours is right here's 2 and here's 3, so this is 2.2 hours. And if I draw a line up to the blue car, which is up here, we'll notice that at that very moment, the blue car is 28 miles from home. Might be able to make that a little clearer to see if I shrink the thickness of the lines a little bit. And so let's see, the answer here then will be 28 miles. Now, of course, we could go the other way also. We could say, well, how long did it take the red car to get 6 miles from home? Let's choose some lines to work with, and let's find 6 miles from home. Here's 0, here's 10, so each of these must be 2, 2, 4, 6. So here's 6. Now we'll notice that the red car, the line from 6 doesn't hit the red car's line until past the 1. And this is important because as we drop this down to the time axis, we'll notice that that value is very clearly bigger than 1, but it's not yet to 1.2. Here's 1, 1.2, 2, 1, 1.2, 1.4, 1.6, 1.8, 2. So this value here is actually 1.1. And so the proper answer here is 1.1 hours. What is not a proper answer is to say, well, it's kind of close to 1, or put something like this, 1. That's not what we want you to be able to do. We want you to be able to make an estimate between the lines. You're not completely guessing. You know it's more than 1, and you know it's less than 1.2. So it's not a guess, but you are estimating between the two. So that's not okay, or even say this is not okay. We don't want you to say that either. 1.1 hours is the proper answer. Now, if you said 1.15 or 1.17, anything like that would be okay as long as it's less than 1.2 and more than 1. All right, question C. What is the general trend for the blue car? Well, the general trend is up. That is, as time goes on, the distance increases. And that, of course, is true for the red car also. Both of these are uptrending lines. Now, which car traveled further in 4 hours? So here's 4 hours. Now, the question of which traveled further is not the same as which car is further from home. Uh, the blue car is clearly further from home. The blue car is somewhere around 31 or so miles from home. But the blue car started at uh, at 24 miles away from home and ended up at about 32. So the blue car only went about 8 miles, whereas the red car went 24 miles. So the answer is the red car. The red car traveled further. It is not further at the end of time, but it is uh, has traveled further. All right. Now we're going to look at the second skill, which is how to compare rates of change between trend lines or moments along a single trend line. So, first question is, which car is increasing its distance from home at a greater rate? Now, this word rate is a word which can be taken a lot of different ways, but really has only one meaning in the context of these graphs. So, what rate means is like how much does one thing change when another thing changes? And so let's compare a couple of things here. Let's compare the blue graph. Let's compare the rate of change for blue. Now, what we're going to do here is we're going to say that blue started at 24, and let's look a minute later, or excuse me, an hour later, where blue was at about, I think I'm going to estimate here, is about 24, 20, 22, 24, 26. So let's estimate, let's round a little bit. It's not quite proper graph reading, but it'll make the math a little bit easier. So the change in distance for the blue is in that 1 hour of time is about 2 miles, and the amount of time it did that in is 1 hour. So that's a rate of change of 2 miles per 1 hour. All right, now let's do for the red car. Okay, now for the red, in that same 1 hour, the red went from 0 to approximately 6. So let's say the change in distance was 6 and the time was 1 hour again. And so that's a rate of change of 6 miles per 1 hour. Okay, so now we can answer the question, which car is increasing its distance from home at a greater rate? Well, at least in that first bit of time, the red car is. The red car is increasing its rate, increasing its distance at a greater rate. Now, for those of you who have had enough math, you might recognize this calculation as the same thing as finding the slope. And so when you see this word rate, you can think, any of you can think slope. So if it's a very steep slope, like the red car, that's going to have a greater rate of change. Whereas if it's going to have a shallower slope, it's going to be a lower rate of change. And this will be greater rate of change. All right, so you could go in and do a calculation like this to determine which is greater, but I would much rather have you connect the word rate to slope. And that way it becomes pretty visual to see, whoa, which one's steeper? and that's the easiest way to tell. Now let's tackle question B then. Does the blue car move at a greater rate early in its trip or later in its trip? So let's look. We're going to look here and maybe over here. In which case is the slope greater, early or later? And of course, those of you who understand the concept of a line know that the slope is the same throughout the whole line. That is, it's just as steep here as it is here. So the answer is here, it's the same. Well, let's get a different color here. Same all the time. And the same thing is true for the red car, because the slope of the red car's graph is always the same. At no point is it steeper than some other point. And then lastly, which car is moving faster? Well, this question, which car is increasing its distance from home at a greater rate, is the same thing as saying which is moving faster. And you might be able to tell that by this thing of like miles per hour. And so the red car is moving faster. Now I'm going to tackle the second skill, how to compare rates of change between trend lines or moment along a single trend line, with a second graph, and so that you can see how this concept applies when the trend line isn't actually a straight line. So let's look at the orange car's motion and the green car's motion. How do the general trends of the cars differ? Well, green increases its distance from home, while orange decreases. All right. The orange car is actually getting closer to home, while the green car is getting further from home. Now, does the rate of change of distance for the orange car increase or decrease with time? Now, this is a question we have to be very careful about answering, because it's not asking, does the distance increase or decrease? It's asking whether the rate of change increases or decreases. The distance clearly decreases. We start at 32 and it ends up here at 0. So they end up back home. So the distance from home actually decreases, but that's not what this question is asking. This question is asking, does the rate of change increase or decrease? So once again, when we see this word rate of change, I want you to think slope. So this is like asking, does the trend line here get steeper or less steep? Well, how do we see that with a curve? Well, we actually can just imagine, like earlier on here, let's imagine how steep is the graph here? Well, here it's about like that steep, whereas here it's about like that steep. Like it looks to me like it's much steeper here, and here it's shallow. And so when we're asked about the rate of change, this is saying shallow steepness or low steepness is the same as saying small rate of change. And steeper means big rate of change. So, does the rate of change for the orange car increase or decrease? Well, it starts with small and ends with big rate of change. So the answer is its rate of change increases. Now, once again, you want to be careful because most human beings aren't very good at thinking about rates of change. Most human beings will look at this graph and say, well, the orange line is going down, so therefore the answer must be decrease. But we're not asking about the numbers. We're asking about the rate of change. And again, that's the steepness, and the steepness increases. Let's look at the last one here. When is the rate of change for the orange car greater, near 1 second or near 3 seconds? Well, I kind of tried to play that out a little bit here. Near 1 second, it's not very steep. Near 3 seconds, it's pretty steep, or at least compared to there. So we're going to say 3 seconds is where the rate of change is the greatest. Once again, we're not asking how far it is, which is greater. We're asking the rate of change. If this was like, is the car further from the house at 1 second or 3 seconds, then the answer would be 1 second. It's much further from the house than at 3 seconds. But we're not asking about that. We're asking about the rate of change. The rate of change relates to the steepness of the trend line, and it's steeper here than here. So the rate of change is greater at 3 seconds than at 1 second. Now, I imagine throughout this video you've had some questions, and I would encourage you to bring those questions to your teacher tomorrow or whenever you discuss this video in class.